Hello and welcome to my video lesson 5.7 on interpreting graphs of linear functions. So to begin with, just a reminder from last lesson as well as from grade 9 math, as well as looking forward into the next unit. This is slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept. This is very important when interpreting graphs because from an equation, you can determine the answer to a word problem. Or from a word problem, you can make the equation. Or from a graph, you can make the equation. Or from a word problem, you can make the graph. And all of those things. So this is a very, very important concept. You need to know that m is the slope, b is the y-intercept. This is absolutely key. Okay, now the b being the y-intercept, that's just wherever where x equals 0, y equals b, whatever that is, whatever value that is. Okay, but the rate of change, or the slope, is a little bit more complicated. It's rise over run, or change in y over change in x, which is written like this: y2 minus y1 over x2 minus x1. So draw the following on the graphs below. So now that we know that piece of information, we're going to try to draw these on the graph. So we've got this one. Always start with your y-intercept. So we're going to put a -2 down there. And then we're going to use the slope next in order to draw the next point. So this is 3 rise, 2 run. 3 rise, 2 run. And you can also go backwards, 3 down and 2 run backwards. And so now we have this line here, and I won't make a perfect straight line, but you should use a straight edge if you can. It's going to look kind of like this. Okay, so not 100% perfect, but pretty close. This is good enough for you to get the marks. I would prefer a straight edge. Okay, so I would recommend pausing the video now and trying this out for this second part of the question. Okay, so you're going to start with the y-intercept, which is a +4, and then you're going to use your slope to determine what to do next. Now, if it's a whole number slope, just remember it's like 2 over 1, or -2 over 1. So we're going to go down 2 over by 1. Down 2 over by 1, down 2 over by 1, down 2 over by 1. Oh, my drawing is not super precise, but it's close enough. Okay, so that's what that one looks like. It should be, again, more straight, but, good enough. All right, looking down below, I've got 3 different graphs. Which of these graphs match the equation given? So I would recommend pausing the video now, trying it yourself, and then seeing if you can get the same answer as me. Okay, so it's as easy as drawing it. Just keep in mind that what I would do is I would, like if it's a multiple choice question like this, I would just cross out one at a time based off of what I know. So this one cannot be the right answer because this has a negative slope. So it cannot be the right answer. Okay, this one cannot be the right answer because the y-intercept is +2. So this must be the correct answer. Okay, so now you can double check that by double checking the y-intercept, and then you count 1, 2, 3, 4 up, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4 up, 5 to the right, etc. And you can also, 1, 2, 3, 4, 5, 4, 5. There you go. You can also do that and just draw it on top. Okay. Here's the next question. it's asking to draw a graph that models the situation below. So here's the graph. You can draw it yourself based off the word problem, but here it is. Okay, so what we're going to have is the fee in dollars. We're going to have the time in hours, and this is based off of a previous units when we talked about manipulated versus responding variables. 0, 1, 2, 3, 4, 5. We're going to go to here and call this 50. 4, 5. Call this 100. 2, 3, 4, 5. Call this 150. And then 1, 2, 3, 4, 5. And call this 200. Okay, that's going to be easier to manage. Okay, so our first point is going to be at 20. And then 55. And then 90. And then plus another 35, so 125. And then 160. And then 195. There you go. Sorry, I apologize about that. Oh, we should also have a title. So, cost of plumber per. No, we'll just say that. That's probably simple enough. Okay, so 195 is the max that we went to, so that's how I help determine the scale. Okay, one last question. Here's a graph and determine a few things about it. There are actually kind of three different linear functions happening here. There's a linear function while it's being drained. Okay, and for that one, the y-intercept is where x equals 0, y equals 1,500. So this is the max capacity of the hot tub. Okay, that's what it is talking about. Okay, then it lowers, it drains the whole thing. So 1 hour is the x-intercept, and it's the time to drain, to empty. Okay, the rate of change, what does it represent? So the first rate of change, because there's actually two sections, is negative, and then what you do is you go, well, actually, let's take y2 is 0, and minus 1,500, okay, and then x2 is 1, minus x1 is 0, so we get negative 1,500 over 1, or negative 1,500. This is the basically the speed. So 1,500 liters per hour is the speed at which it was draining. And then also, it's the same rate of filling later. So there's another, you can look at the filling rate on the other half, and it's got the same rate as well. What are the domain and range of the function? Well, x is greater than or equal to 0, and less than or equal to 2.5 hours. Actually, I should use t for time. And the volume is less than or equal to 0, or greater than or equal to 0, and less than or equal to 1,500 liters. So I hope this video helped you better understand interpreting graphs of linear functions, and good luck.